Hello, this is Andrew with Missing Remote. This is the second part of the look at the specialized S-Works Power Crank Power Meter. In this video, we're going to look just at the power numbers compared from the S-Works Power Meter to Wahoo Kickr. Unfortunately, I don't have another power meter that I could use to compare outdoor rides with the S-Works. So all I can say there is that the power numbers, both in average and observationally, are consistent with when bringing speed into the equation, are consistent with what I would expect to see from a power meter for the given speed. So you kind of take that for what it's worth. It's hopefully something I can sort out in the future, but budget is not unlimited for these projects. So we have two structured workout kind of rides and then one free ride. I've recorded quite a few other rides. It's just that these three kind of capture essentially what I expect to see or what I have seen in all the other ones when I was looking at them. It's important to note that in this case, cadence is captured for the S-Works by the S-Works power meter, and cadence is captured for the Kickr using a Wahoo cadence sensor that was placed on my shoe, where the cadence sensor for the S-Works is the crank itself. That's consistent with all of these. So there's a couple of things that I found to be pretty interesting, and you can see here where the cadence is relatively the same between both cadence tracking devices, where the power from the Kickr drops in a way which is somewhat unexplained. That shouldn't happen. And you can see it again here, where it drops, where cadence tracks relatively close. And where we have a drop in power, we do see a drop in cadence on the S-Works and the Wahoo sensor, but the S-Works goes down much quicker than the Wahoo Kickr does, and then recovers at about the same rate. So I'm not sure what's going on here. I just wanted to point out that there's a bit of a difference there. And then here, where the cadence actually goes to zero, and we can see that with both of the cadence sensors, the S-Works drops to zero with power very quickly, and in a way which is very consistent with what we see from the cadence, where the Wahoo Kickr actually never hits zero, even though looking at the cadence we know that it should have, because no output, no spinning means no power. So that's an interesting thing to note as well. Otherwise, there is some difference. We actually expect the S-Works to be a little bit higher in most cases because of where power is measured. It's measured at the crank with the S-Works and measured at what would be the wheel hub with the Kickr. So it's normal to see somewhere between 3 and 5% lower number with a hub-based versus a crank-based. Power meter train efficiency loss is what causes that. I don't think there's anything else I wanted to point out here. Oh, here's another example of where the Kickr kind of drops power where I wouldn't expect it to. Because it's important to remember that this is a structured workout ride, so power here should be relatively consistent and fixed during the ride. So yeah, and then this other one, same kind of ride. Power slightly higher, 50, 40, 40, I think, was what I calculated earlier. You do see a bit of a cadence difference between the S-Works and the Wahoo cadence sensor, which if we're only looking at these two on the right side, that could explain some of the difference in power, because cadence is an important or an essential part of calculating power. But here we see a very slight difference in cadence, RPM for this spin up for the sprint here. But we do still see a significant difference in power between the S-Works and the Wahoo Kickr. Then looking at a free ride, we can kind of see again that same thing with the Kickr, where it drops power in a way which I wouldn't expect it to. As the cadence comes down, the power drops a lot faster, and probably in a less explainable way than it does with the S-Works power crank. Otherwise, they do track relatively closely, exhibiting very much the same kind of stuff that we see, whereas the S-Works is slightly higher, reacts a little bit faster. Oh, here's another place where the Kickr drops out. Although some of these might be environmental, I don't know. So I guess the takeaway that I got from this is that is more that the Kickr might not be as good of a source of power as I expected it, is that I thought it was. Because I'm seeing the issues that I'm seeing appear to be more with the Kickr than they are with the S-Works power crank, which is in some ways confidence inspiring when it comes to the S-Works power crank, but not so confidence inspiring when it comes to the Kickr. Hopefully this was useful. Hopefully I didn't mess it up too horribly. If I did, please let me know. I'm happy to look at what other people have to say about this kind of analysis. It is interesting. It's not something that I mean, I do it personally quite frequently with the rides that I do inside, just to kind of have a look at how things are progressing, what I'm doing, that sort of thing. But if there are things that you think I could do better, please let me know. I'm happy to have a look at that and respond as best as I can. Please like the video if you liked it. If you didn't, and you don't feel like leaving a comment for why you disliked it, go ahead and hit that dislike button. But otherwise, comments for dislikes are usually much more useful than just whacking the dislike button, because then there's something actionable. Either I can ignore it or I can fix it. Yeah, thanks for watching. Cheers.